Welcome to the lecture on methods of comparison of alternatives. So, now we will go to the new chapter where we are going to discuss about what are the different methods of comparing the different alternatives. In the case of financial world, many a times we have some different alternatives. We have option 1 or option 2, and the cash flows or transactions at different times are basically provided, and we need to come to a decision, and for that we must find the value of these transactions at a particular time. So, how to calculate what are those bases of comparison by which you can talk about these alternatives. So, we are going to have a discussion on that in this lecture. So, a comparison of alternative investments is required for decision of whether to accept or reject any investment. So, that is many a times the need of the hour. Then it is required to also know how to compare the alternatives on an equal basis for selecting the wisest alternative from an economic standpoint, and for that there are basically 4 ways by which you can compare these alternatives, and these 4 ways are basically the present worth, annual equivalent, future worth, and the internal rate of return. So, these are the 4 methods of comparison of the alternatives, and we will talk about them one by one. So, present worth criterion. Now, present worth of an investment is the net equivalent amount at present time. So, basically what we see many a times that you have the investment or the transaction of cash transactions at different times. So, you can just get these present worth values of all those transactions, and it represents the difference between net receipts and net disbursements made at present time for a specified interest rate. So, what it tells that in a particular cash flow diagram, you will be having either receipts or disbursements. So, with all the receipts together, it will have a net receipt at the present time. Similarly, all the disbursements taken together, you will have a net disbursement, and the arithmetic sum of these two, because one is positive, one is negative. So, that will give you the net present worth values. So, basically based on that you can compare. Many a times the situation comes like you are going to get something today, and maybe in another case you are going to get the other sum maybe 5 years later. Now, you have to compare these two alternatives, like bank 1 may tell you that I will give you 50,000 rupees now, and bank B will tell, bank 2 will tell that it will give you 80,000 after maybe 3 years, and and once you know the rate of interest, in that case you can just or there are many payments in between at different times. In those cases you can compare by finding the present worth. So, what is the worth or the value of all these transactions at the present time? When we take that into comparison, then that criterion is known as the present worth criterion. It is also known as the net present worth and expressed as PWI. I is the interest rate. So, at a particular interest rate, what will be the present worth? So, that can be calculated, and if Ft is the net cash flow at time t and n being the service life of the project, in that case if you look at how can you find this PWI will be t equal to 0 to n, you have Ft into P by F IT. So, all these Ft's I mean F1, F2 or F3 or so, all that will be individually multiplied with this factor F P by F IT. So, if suppose there is a payment on at the end of third period, so it will be multiplied with factor p by f I 3. So, that will give you the equivalent value at the present time. Then so one by one individually for all the cash flows f1 to fn, you have to individually change it into the present worth, and then all together you have to add or subtract them, and then you have to find these net present worth value. And depending upon the value of PWI, decision on any investment can be to accept it, be indifferent or reject it. So, when you have two options and you have to come to a conclusion, then you find the present worth, and ultimately you have to see that in whatever case, in whichever case PWI is more, you can go for that investment, where when you have to get it, or if you have to pay it, then in that case you can contrarily you can think of taking that investment alternative which is giving you PWI lesser. So, that way you can use these PWI methods for the different cases. Now, the next method which is present to us is about the annual equivalent criterion. So, similar to the present worth criterion, you have another criteria, that is annual equivalent criterion. Now, annual equivalent criterion, you are going to get the equal annual amount for the different alternatives. So, you have the cash flow diagram, and for the two you are going to have the annual equivalent value. So, it is this annual equivalent worth criterion, so that is providing basis for measuring worth of an investment by finding equal payments on annual basis. So, we know that by multiplying any payment with respective factors, like if you have P, you multiply with A by PIN, so it will give you the equal annual payment series. So, for any transaction you have to multiply with the respective A by PIN factor, and accordingly you will get the equal payment series value. And for the different alternatives, you can have the value of AEI. So, annual equivalent is the net sum of annual receipt and annual disbursements. So, if you have suppose two financial alternatives, in that case AEI 1 and AEI 2 will be calculated. Now, that can be calculated by many ways. One of the way will be that you get the present worth, as we discussed that in the last point was the calculation of PWI. So, once you calculate PWI, then that will be multiplied with the factor A by PIN. So, that will give you the annual equivalent value. So, or if you even if you can get the future value, and then also you can multiply with the A by FIN. So, that way you can get the annual equivalent value, and that will be basically the parameter to compare the two types of cash flows. So, depending upon the value of AEI, decision on an investment can be to accept it, be indifferent or reject it. Similar way, like if you are if you have to pay, in that case you have to see that you are getting the lesser value, or if you are on the gain side, you can go for the larger value of AEI. And annual equivalent basis of comparison is preferred in case of repeating type of cash flows. Many a times you prefer this way. It is very easy to think that the present worth type of comparison, present worth value calculation has explicit meaning. You know that if it is larger, you will say that yes, we should go for it. but then many a times for some repeating type of cash flows, and that too it is going on for very large time. In that case it will involve large and large calculation, it will take more computation time, and also it will in that case this annual equivalent basis is having more meaning, that because it will tell you, because it is repeating. So, the same thing will be repeated in future also. So, the annual equivalent value, if you take that circle or that period in which the cash flow is there, which is further going to be repeated in the next periods, in that case you just take the annual equivalent value, and that will be representing the nature of the investment, and you can come to a conclusion for such cases. So, we can see, we can also find that this method is very much useful for the repeating type of cases. Like for example, if you see that you have one cash flow diagram where the cash flow diagram goes like this. So, at 0 time you have minus of 1000 rupees, and then at 1 you have 400, and at 2 you go for 900. Then at 2 again you have disbursement of minus 1000, and at 3 again you have the receipt of 400, and at 4 you have receipt of 900. So, further you have the disbursement of minus 1000, and then this goes on continuing. Now, if you look at this, if it is a repeating type of cash flow, now for them it is advantageous to look into the aspect that you must calculate the annual equivalent value, that is having more meaning. Now, what you see is that you see that this cycle is basically getting repeated. So, further you are going to this cycle. So, same thing is going to be repeated. So, in that case it is better that you break down this type of cash transactions into such a manner that you get the annual equivalent value, and they will be more appropriately representing the case. So, what you will see that and also this will, because this cash flow is going on, and what you see that you have n minus 2 period, then you have n minus 1 period, and then you have n period. So, it is all given that it is minus 1000 here, and then you have further at n plus, so you will have all these values of 900, then you have also this as 400, and then you have here as 900. So, this is given. So, what you see that this is ultimately same thing is repeating. So, that such a repeating type of cash flows we can solve by looking at only this. So, whatever is the annual equivalent value for such case, it will be remaining the same. So, basically this will represent the annual amount, and that will be same whatever be the time horizon. So, annual worth basis of comparison, annual equivalent basis of comparison holds very much good for such kind of cash flow transactions which we see many a times. Now, if we have to solve for such case, what we see that if there is a rate of interest I is defined as 10%. Now, in that case what we see is that we will calculate this annual equivalent at 10%. Now, what we see that for this you have minus 1000 is the disbursement. So, you will take it minus 1000. Now, 4000 this 4000 is to be multiplied with P by F. So, this 4000 also to be its equivalent value is to be found at 0 time. So, this 400 it will be multiplied with p by f 10 1. Then you have further you have this 900 value. So, this 900 value will be multiplied with p by f 10 2. So, this value is basically telling you the present worth value for this repeating type of flow. Now, this whole amount is must. So, this is giving you the present worth value. Now, for this time domain of 2 years, you have to find the annual equivalent. So, what will be the equivalent annual payment receipt or disbursement? For that you have to multiply with the factor a by p. So, because you know p and you have to find a. So, you will be multiplying with a by p 10 2. So, you can calculate this by knowing all these factors from here. Now, p by f 10 1 will be 0.9091, then you have p by f 10 2 is 0.8265, and then a by p 10 2 is coming out as 0.5762. So, you can refer to the 10% interest table and you can get these values for the different factors, and once you see that you will get the value as 61.93. So, 61.93 basically is the value of the annual equivalent. Now, this 61.93 will be for this. So, it will be same as, so it will be like at 0. So, then 1 and 2 will be 61.93. So, similarly, if you go further, then 3 and 4 will also be 61.93. So, this 61.93 is not going to be changed. So, it is going to be defined. So, for such kind of repeating flows, this kind of analysis of the comparison or method of the comparison, like using the annual equivalent value basis, that has more meaning as compared to other comparison methods like present worth, and even in future we will discuss about the future worth methods and or so. So, this is about the annual equivalent method of comparison. Next is the future worth criterion. Now, future worth of an investment is the difference between equivalent receipts and disbursements at some point of time in future. So, in this case you are going to have the future worth values, and then you are going to compare how which one to be decided, and if f t is the net cash flow at time t and being the service life of the project. So, we know that we are going to have this formula future worth I for any particular interest rate will be f t into 1 plus I raised to the power n minus t, because as we move in the direction of time, you will have certainly lesser and lesser time available for it to earn interest. So, that is why the power becomes n minus t, and this is how you get the future worth I. You can even see that what happens that your future worth will be basically when you have many transactions at all the different times. So, you will have f1, f2, f3, f4, f5, whatever it be. So, f1, f2, f3, like f4, f5. So, this way t and it goes to n. So, suppose if you trying to find the value at future, now this f1 will have more time. So, it is for basically it's when its future value is to be calculated, you will be having n minus 1 time of compounding period. So now whatever Fn is there, if suppose you have any Fn is there, it has no time, so it is 0, n minus n is 0. So that is why what you do is that for you are multiplying with that power 1 plus I raised to the power n minus t. So that's basically we are we have if there is f0 also, so you have f0 and that will be multiplied with f by p in. Then if you have f1, so it will be f by p I n minus 1. Then if you have f2, then it is f by p I n minus 2. So this way this factor will go, ft will be there, so f by p I n minus t. So this way it will go and will go up to fn will be f by p I 0. So that way it goes, and so that is why Fwi when we write, it will be summation of this I equal to 0 to n, and it will be Ft into f by p I n minus t, it comes out as. So that way we are taking the summation and we are getting the future value, future worth, and this is known as the future worth criterion for finding the these equivalent future values, and then deciding as to which one is better alternative. Now what we know so far, that we have three methods of comparison. One is that present worth method of comparison, PWI. Then you have the annual equivalent method of comparison, AEI, and you have future worth comparison, FWI. Now what we see that FWI and AWI, or you can say AEI, annual equivalent, that is are seen to be PWI times some constant values when I and n are fixed. We know that we have to multiply with a certain factor, and this factor will be depending upon I and n. So once we fix the I and n values, then basically they are basically some constant values multiplied by one or other factor. So future worth, annual equivalent, and present worth are the consistent basis of comparison as long as I and n are fixed for any two alternatives A and B. And what we see that what we get is that when we have to get the future worth and the present worth, then you multiply with the f by p I n. So similarly, if you have to get other things, AWI, AEI, so you have to multiply with some other factor like that. So what we see that normally this relationship holds quite good. PWI A upon B will be same as AWI A upon B, or it will be same as FWI A upon FWI B. So basically all these comparison, their ratio becomes same. So they are basically the measures of they are the measures of equivalence, and the difference only is that at what point you are basically comparing them. In one case you are comparing at present time, in another case you are comparing at the future time, and in one case you are comparing by taking the annual values together. So that is the only difference between them. Next what the base of comparison is an internal rate of return. So for any investment, the internal rate of return is that rate of interest at which the equivalent value of the receipts is equal to the equivalent value of the disbursements. So that is how your internal rate of return is defined. So we know that you have in any investment, you have the receipts and also you have the disbursements. So this internal rate of return, you have all the receipts and also all the disbursements. Now when you are going to calculate the equivalent value of all these receipts, be it the present worth or be it the annual equivalent or be it the future worth, their present worth value of all the receipts and the present worth value of all the disbursements, if you take the net value of that, then it should be 0. So, for that for whatever rate of interest this value becomes 0, that is known as the internal rate of return. So, it is the rate of interest for which present worth of any investment is equal to 0, that is summation of t equal to 0 to n f t 1 plus I star and raised to the power minus t. We know that when you have any transactions going on in the future, then its present worth will be calculated by using the factor p by f I n, and p by f I n is 1 plus I raised to the power minus n. So, this 1 plus I raised to the power minus t, all that will be taken out for individual transactions, and its summations must be 0, because f t may be positive or negative. It will be positive for receipts, it will be negative for the disbursements. So, that how you calculate these internal rate of return. So, the equation or the value of I for which this condition is satisfied, that will be only the value of the internal rate of return. For example, suppose you have been given a cash flow pattern which talks about this following values, like you have end of year and you have cash flow. So, that is f t. Now, at the end of year 0 you have minus 1000 rupees, and then at the end of you have next 5 years your cash flow transaction talks about minus 800 in the first year end, and then 500 for the next 3 years, and in the end you have 1200 rupees. Now, for such transactions, if you have to calculate what is the rate of return for or internal rate of return for such investments, then as per definition you have to calculate the present worth values and of all the receipts, and that must be equated to the present worth values of all the disbursements, and then or else the net present worth values must be equated to 0. So, that time you have to take plus and for disbursements and minus plus for the receipts and minus for the disbursements. So, if you try to define the internal rate of return, so the internal rate of return will be I star, and for that I star your present worth ultimately will be 0, and for that if you take the present value, minus 1000 is anyway it is the time at 0 time. So, you have this is your present worth itself, then you have minus 800. So, this will be multiplied with p by f I 1, p by f I star 1. So, certainly it will be by 1 plus I star. I star is the rate of return. Then you have then you have again you have 3 500s. So, you have to convert them to the 3 the present value. So, you can go for the 500 and multiplied by p by a, and what we do is you can get this 500 from here, and then rest 700 will be remaining. So, you can have p by a 12 4. So, this 500 will also be taken from here, so that you have your 700 is still remaining, and p by a 12 4 will define the value at here. So, you have to further multiply with p by f I 1. So, it will be p by f. So, this is I star, this is I star, and p by f I star, then you have 1. So, and then you have 700 remaining here. So, this 700 will be multiplied with p by f, and this is 5 periods. So, you have I star and 5. So, this is how you will have an equation, and the value of I star which will satisfy this equation, that will be your the internal rate of return, and that is how you calculate this rate of return in such cases. So, you can solve, and you can by hit and trial, and by trial and error maybe you have to use it because it will be all raised to the power -4 or so. So, by using that you can come to certain interest rate values, and it may be used because you have to go take some I star values by by check by hit and trial, and then maybe you can do the interpolation for finding the I star, and you can solve such problem, and you will see that it will be coming close to 12.8%. So, that is how you get. So, for 12.8% basically this altogether quantity will be 0. So, these are the 3 4 methods for the comparison of the alternatives. They are the basis of comparison of the different alternatives in financial world. Thank you very much.